Welcome to our YouTube video on electrical circuits. In this detailed explanation, we'll dive into the fundamental components and principles that make up electrical circuits. From voltage sources to resistors, capacitors, inductors, and switches, we'll cover it all. Whether you're a beginner or looking to refresh your knowledge, this video will provide you with a solid understanding of how electrical circuits work. So, let's get started and explore the fascinating world of electrical circuits together. Electrical circuits are systems that allow the flow of electric current through various components to perform specific functions. These circuits are composed of several interconnected elements, including voltage sources, resistors, capacitors, inductors, and switches. Let's delve into the details of these components and how they interact within a circuit. Voltage sources. Voltage sources provide the electrical energy needed to drive current through a circuit. The most common voltage source is a battery, which generates a constant potential difference or voltage between its terminals. Alternating current (AC) circuits can use power outlets as voltage sources, where the potential difference periodically changes over time. Resistors. Resistors are passive circuit elements that resist the flow of electric current. They are characterized by their resistance, measured in ohms, omega. Resistors dissipate electrical energy in the form of heat and can be used to limit current, divide voltage, or create voltage drops. The relationship between voltage, V, current, I, and resistance, R, is defined by Ohm's law. V equals I asterisk R. Capacitors. Capacitors store electrical energy in an electric field. They consist of two conductive plates separated by an insulating material called a dielectric. When a voltage is applied across the plates, charge accumulates, and the capacitor becomes charged. Capacitors are characterized by their capacitance, measured in farads, F. They are widely used in circuits for energy storage, smoothing power supplies, and filtering signals. Inductors. Inductors store electrical energy in a magnetic field. They consist of a coil of wire that generates a magnetic field when current flows through it. Inductors resist changes in current and are characterized by their inductance, measured in ohms, H. They are commonly used in circuits for energy storage, filtering signals, and generating magnetic fields. Switches. Switches control the flow of current in a circuit. They can either complete or break the circuit path. When a switch is closed, on position, current can flow through the circuit. When a switch is open, off position, the circuit is interrupted, and no current can flow. Components in a circuit can be connected in two different ways. Series circuit. In a series circuit, components are connected sequentially, one after the other. The same current flows through each component, and the total resistance of the circuit is the sum of the individual resistances. The voltage across the components adds up to the total voltage of the circuit. Parallel circuit. In a parallel circuit, components are connected in branches, where each component has its own separate path to the voltage source. The voltage across each component is the same, while the total current flowing into the branches adds up to the total current of the circuit. The total resistance in a parallel circuit is determined by the reciprocal of the sum of the reciprocals of individual resistances. Circuit analysis techniques, such as Kirchhoff's laws and Ohm's law, are employed to analyze and design electrical circuits. These methods allow engineers to calculate voltage drops, current flows, power dissipation, and other circuit characteristics. It's important to note that electrical circuits can become more complex with the addition of integrated circuits, ICs, transistors, diodes, and other specialized components, enabling a wide range of applications, from simple lighting circuits to complex computer systems. Thank you for watching our video on electrical circuits. We hope you found the information insightful and helpful in understanding the essentials of circuitry. If you enjoyed this video and want to stay updated with our future content, don't forget to hit the subscribe button and click the notification bell. We appreciate your support and look forward to bringing you more engaging and educational videos in the future. Stay curious and keep exploring the world of electrical circuits with us.